Let's read. Okay, so password philosophy is called day 2. Your flight departs in a few days from the coastal airport. The easiest way down to the coast here is via the toboggan. What's this? Sled, traditionally used by children. Traditional form of transport. Okay, I'm not sure what we're seeing here, but okay, sure. Oh, so it's kind of like a sled kind of thing. Bump slider, okay. So let's see. What I like about the quadratic runtime solution is fine here. Oh, what I like is that the quadratic runtime solution is fine here with a lot of coding. Games you often can't use a naive solution in higher level languages because they exceed the time limit. So let me think. I mean, I'm not even sure there would there be we could do something like sorting the list maybe, and then for at least for the third number we could make sure that we're only looking in the part where in the area where it could be, maybe, right? I guess you could do some tricks where you know that if you add 3 small numbers you will never get to 2020, right? Or something like that. So maybe if you do some analysis on the list, and I don't mean compile time, of course, at random, right? You can sort it, and then maybe there could be some tricks to make it faster, but I'm not sure when that would start paying off. Yeah, I'm not sure if you had something else in mind. Okay, so the shopkeeper at the North Pole toboggan rental shop is having a bad day. Something wrong with our computers. We can't log in. Oh, sure. Ask the programmer to fix your computer. You ask if you can take a look. No, I would never do this. I would be like, sorry, I have no idea how to work computers. I'm sorry. I will not fix your printer. Their passwords database seems to be a little corrupted. Some of the passwords wouldn't have been allowed by the official toboggan corporate policy that was in effect when they were chosen. Okay. Try to debug the problem. They have created a list, your puzzle input, of passwords according to the corrupted database. And the corporate policy when that password was set. Okay. For example, suppose you have the following list. Each line gives you the password policy and then the password. The password policy indicates the lowest and the highest number of times a given letter must appear for a password to be valid. For example, 13 means that the password must contain at least 1 time and at most 3 times. Okay, so this means that the letter A needs to be at least 1 time and at most 3 times, and this means that the letter B has to be at least between 1 and 3, and then this means that C has to be between 2 and 9 times. In the above example, 2 passwords are valid. The middle password, C, D, F, G is not. It contains no instances of B, but it needs at least 1. The first and third passwords are valid. They contain a 1A or 9C, both within their limits of their respective policies. How many passwords are valid according to their policies? Okay. So we need to do some parsing here, right? I don't think there's a way around it. I don't really want to do regex, because I've never done regex in Haskell, and I don't really want to start now. So maybe we write a mega parsec parser here, which will be kind of a bit more complicated than I was hoping we'd do on day 2, but we'll definitely need parsers at some point, right? So might as well bite the bullet and start import mega parsec here. I don't think we'll need anything else though. 1, 2, 3. We'll just do some. Yeah, we could do some splits, I guess. But then there's also spaces that we need to split over, right? Maybe the show instances could work, but then like I really hate using the show and read instances. Sorry, the read instances. And I think this parser shouldn't be too hard to write, so I saw my friend's regex, Python regex. I'm never jealous of other people's regexes. I'm happy. I'm always happy to write a parser than like. Yeah, I'll just do a quick parser. I think it should be pretty fast to do. But we'll see. Time me and tell me how long it took actually. I think. Oh, we need to run HPAC. Hopefully we already have megaparsec built, so we don't have to wait too much for it to build. I really hope. Or maybe it's not even trying to build it until we use it. Maybe. We'll see. Okay, so let's have a quick go here, right? So type parser is parsec. I always forget this type, so I'm bad at memory. Parser combinators. Oh yeah. Parsec. I think it's the type, but not here. It's from megaparsec. There we go. So E is the error type. Can we use void as the error type? I don't remember. Or unit or something. I don't even remember if I can use void or unit for the parser type. Was there a quick tutorial? Oh yeah, there we go. Yeah, we can use void as the error type. There we go. So parsec, so we could use like m.parsec void, and then let's just do strings because we don't really need text here. I think they're not too big, and I don't want to import text as well. Okay, so that's the parser type. Let's import megaparsec and void. I love Haskell language server. Okay, so let's see, where is the format here? There we go. Right, so let's think about the data structure that we want to get out of like the result of parsing this, right? So first of all, it's a list of things, right? So that's easy. So then what is in each line? Well, it's like a bounds, right? Minimum and maximum, right? So should we have a record type? I kind of hate record types in Haskell. Well, at least compared to PureScript, but it's still better than not having record types, right? So password entry, maybe we could use the name. And then we have like minimum with like an integer, max as an integer, char as like the single letter here, and then password as a string, right? Okay, I'm not sure if we want to derive anything. We'll see if we want to derive stuff. We'll check later, right? And we want to do like a parser for password entry, right? Okay, so what do we need to do? Well, we need to parse like numbers first, right? So a number. So let's see, where's the combinator for that? Where are we here? Contents. So was it in Lexer or was it in char? I think it was in Lexer, like the numbers. I always mix this up. Yeah, there we go. Right, so yeah, decimal is probably what we want. Okay, so we just literally need like decimal. We could use do notation to make things simpler. So min. So we'll grab this first, and then we need to grab what? Like a dash, right? A single character dash. I'm pretty sure char is in the other module though. So this was like lexer, so let's prefix it, and when we import it, and then I think this is, we can use char here, or maybe just strings. Let's do a little banny ban here. Where are you? Oh, not this. Okay. Digits, no. There we go, char, right. And this is in like c.char this, right? We ignore it. Then we need to do another number, so max is l.decimal once more. Then we need a space. I think this is like, I think this also has a space, right? Control space char. There we go. Actually, let's start importing things, right? Because it's getting a bit hard to see. So char lexer, and then megaparsec char. Okay, and the error here is that the last line cannot be a bind, right? So we need to finish the parser up. Okay, and then we need to parse a single character, which we kind of assume should be a character, right? So maybe we can do alphanumeric char. That seems reasonable to me. Okay. Yeah, like the advantage of this is you don't have to worry, like it could be it could be 3, like 10 or 15 or whatever, right? You don't have to worry about whether if it's bigger than 9, right? Otherwise you need to do char by char and then see whether this is like 10 or like how many characters the number has. Okay, and then we need like this and space, right? And of course we could have used it like lexers and like tokenizers and so on, but I don't think we will. We could even use like string here and then do like this and the space just so we can go faster. There we go. And then we need to parse a string, right? So pass. Okay. So we can do, oh wait, this is a string, so I need to, do this, and then we need password as many, I guess. Many this, so many alpha num char again. Maybe we could. I don't love alphanumeric char because like they don't really tell us what kind of passwords are allowed, right? What kind of things are allowed here? Could we have like white space here, and should we count that as a character inside the password, or like non-alphanumeric things? I would assume not. So I'll just do this, right? And at the end we can do pure. I think we can do this, and then we need to add some what's the problem here? Prelude. Hiding min max. Let's import many. Actually, yeah, let's replace it m.many. Oh, we apparently already have the extension for this. Okay, so this parses a single entry, so now we need to parse multiple of this separated by new lines, I would assume. Should we just have this one optionally eat up the new line? So where is the combinator for 0 or 1? I forget. Actually, not even sure. So let's have a. So apparently this thing has it by default. There should be something like something with record. I think record wildcards. I think this is the one. I think it's record wildcards. Yeah. My usually go-to is I just type this and then the error will tell you you probably want to record wildcards, and then I add it, right? I always forget. I never remember most of them because the compiler is usually good enough to to suggest the correct name, right? Okay, so where was the combinator for no, I don't want it. I think it should be here. Like re-exported some applicative things here. Array exports, applicative. Letter char. Yeah, maybe. I think that's definitely a possibility. Data types. So what was sum? Sum assumes it should be at least one, right? One or more, zero or more. Yeah, I guess we could just do many, right? Because many is zero or more. So a new line. And then like if we have new lines, we can just eat them as soon as we find them, so we don't have to worry about how we do like multiple lines, right? And that should be pretty fun, pretty good. Okay, and then the actual, so this is like entry parser actually, right? And then the actual parser would be because we need multiple of these, right? So parser is m.many of, I think they should be good. Yeah, there we go. Okay, so then where are the combinate or the functions which allow us to, well, not here, to read stuff, right? So go from a parser to, it should be stuff with like maybe, and so let's have a look. Parse maybe. Yeah, I think this is what we want, right? So we need maybe m.parse maybe. Well, no, so we probably need a file. So is there something which works over files? There should be some combinators in megaparsec which work over files. Thought it would be here. Maybe inside stream. Not here. File. I mean, I could just... I'm misremembering. There is no... like you pass the input directly. I mean, I could just read the file directly. That's also fine. Okay, so we could do something like read file. And then parse maybe. Okay, so what do we want to do? Okay, let's just do syntax because I don't want to confuse people who are maybe not used to not using this syntax. So let's read the file. So like the raw input is this. And then we want to what? Parse. Well, the parser is pure, right? So we could do let parse result equals to, or maybe we could just do case m.parse maybe, where we give it the parser as the and the raw input off. And then if we get nothing, then we just do error, parse error, parser error. That's fine. And then just access like a list of password entries. Then we. Okay, so what was the requirement actually? What are we doing? How many passwords are valid, right? So we need to count how many are valid. Okay, So is there a function which goes from, well, I guess filter and then count or something, right? Yeah. So I need something like filter is valid over access, and then like count, and then we need to length, I guess, and then print, right? Yeah, and then we need to define is valid, right? So is valid is a function from password entry to bool, right? Okay, so what do we need to actually do, right? So we need to count how many values are, how many chars are in password, right? Is there a function that does that, or should we just filter? Is there a count? I mean, it should be pretty easy to just filter password char, right? So we need to filter only the chars in password, and then grab the length. Yeah, length. And then this number needs to be in between min and max, right? So maybe we could just let count equals to this, and then in count is greater or equal to min, count is smaller or equal, I guess, than max. I guess those are inclusive bounds, right? At least one and most three, yeah, so they're inclusive bounds. Oh, and this is not the syntax for, yeah, there we go, in Haskell. So what's the problem here? Expected IO string. Oh, we need to give it a path, right? So this is day 2, 1. Okay. I think this should work. This is not the nicest way to do it, but I mean, it's not too bad either. So let's import day 2 then here. Okay, let's test it out, right? Oh wait, we need to save the the inputs. So let's have a look. Yeah, it looks like they're all alphanumeric, so we should be good. There's not even that many. Yeah. Day 2, 1. Okay, so let's see. How many does our program think there are which are valid? Actually, let's see if the parser works first. Oh, there we go, parser error. So what's the problem then? Guess we should look at the we should actually allow a an error message in the parser so we can see what the actual error is. Don't see it immediately. Maybe it's because we reached the end of file and then we're not parsing it. Oh wait, oh no, actually that's fine. We are reading an alphanum chart there. We're reading the space. We're reading the... Oh wait, what's this? Okay, that was the problem. I had an R here for whatever reason. I think that was the problem. Let's run it one more time. Okay, so 560. Let's see if this is the correct answer. Oh, okay. Well, that wasn't too bad. Okay, so let's see about part 2 then. I don't think there's much to clean up here. I mean, wild how closely our solutions conversed. I'll have a look after I'm done because I don't want to get spoiled if you are already fixed the part 2. So I'll definitely have a look. I'm interested in seeing how other people solved it, but I want to, I'll have a look as soon as I finish part 2. So let's do part 2 then. Yeah, I was gonna say that I don't think there's much to. This is where I'm up to actually. Okay, cool. Like the parser could be nicer, but they also don't give us enough data to. Oh, okay, so you didn't do part 2. Okay, so then we can have a look for sure. I just didn't want to get spoiled. Oh, please. But if you don't have part 2 here, then we can definitely have a look-see. Due date 2, mega parsec. Okay, so also char counts. Oh, so you have policy separated and you have a row which has... Okay, so you separated the policy from the actual string in your type. Okay, fair enough. So you have a parse rows, which is a list of rows, which you have a many, and then... Oh, so you put the new line outside the row as a requirement, or as I put it as a like optional in each parser. Okay, so a row, we parse the policy, which is separated, and then this is a separator, and then many characters, and then, okay, have parse integer. Oh, so you didn't know about... Yeah, you actually said that you didn't know about this. Okay. Parse int, char, and then policy min, max, and c. So it's valid. Yeah, I also did the same thing, right? Length and filter. Okay, and then count is just length filter again. Yeah, so yeah, they ended up being pretty much the same thing. Oh, and you also did some tests. Okay, which I didn't do. I just go yellow and try it on the result. Well, I think that if like when things get a bit rougher, we'll get it wrong, and then we'll have to start writing some tests manually and figure it out. But apparently I was had for debugging. Yeah, I was lucky enough to get it right from first go. So when I can avoid doing debugging, I'll avoid it. So okay, while it appears you validated the passwords correctly, they don't seem to be what the official Toboggan corporate authentication system is expecting. The shopkeeper suddenly realizes that he just accidentally explained the password policy rules from his old job at the sled rental place. Yeah, sure. I'll see you next time, Soleil. Thanks for dropping by. At the sled rental place down the street. The official Toboggan corporate policy actually works a little differently. Each policy actually describes two positions in the password, where one means the first character, two means the second character, and so on. Be careful, Toboggan corporate policies have no concept of index 0. Okay. Exactly one of these positions must contain the given letter. Okay. Other occurrences of the letter are irrelevant for the purposes of policy enforcement. So given the same example above, this is valid because position 1 contains an A. So did you say at least one needs to... One of these positions... Oh, exactly one. So it's not at least one. Exactly one of them, right? So it's either 1 or 3. Okay, yeah. So 1, 3 with a B, this is 1, this is 3, so it's invalid. Well, you don't have a B at any place anyway. So this is also invalid because both of them have a C. Okay, I see. I see. Well, min and max are terrible names now. Um, but I guess we'll keep them. We'll probably change them if you know last year's AOC when they kind of did the int calculator, whatever it was called, and then you had to like reuse the same bit of code over and over. If this gets a second use, then I'll start renaming them. But for now, I'll just keep min and max, I guess. Actually, no, let's just rename them. I literally just changed my mind. So call it first and second. Should compile. Okay, we don't need to hide anymore because first and second are not exported by Prelude, so we should be good. Okay, so now we have first and second, just so it's just two numbers. So okay, so then we just need to look at those indexes, right, and see whether we have that character or not, and there has to be at least at one of them. So is valid encore. Okay, so do we even have an exclusive OR operator in Haskell? Or do I have to write it like an animal? Oh yeah, you're right. I always forget about that. Yeah, you're right. It's not equal to, right? So go with what first and go second. Given an integer, I would give you a boolean. So what? We need to look at password of like, is there an @ so given an integer and a list, and then we can get a maybe value. Hello. There needs no, I don't want the unsafe one because like I want to maybe it into like false if it's not there. There is one in Prelude, but I kind of there is really not one in is there no safe version in okay, so let's see where this is defined, and maybe maybe around it somewhere we have a safe version. Actually, why would I even expect that? There's no version of safe head in Prelude, so I hate Prelude so much. Is there something in data list at least? There we go, LM index, right? Oh, but it doesn't go for an index. It finds you the index of a value that you already have. Are you serious? I have to write this. Like, I'll write it. It's not a big deal, but it's so silly that it doesn't exist. Yeah, I'm just gonna write it there. Wait. what am I even doing? It's this, and then it's x and safe index of okay, and then we need the nothing case, right? So safe index of empty list, and let's put it here, and any number, it's nothing, right? Right, because like if so, first time we want to pattern match on 0 and we have a head. Otherwise, if it's an empty list, we're done. And otherwise, okay, this would have a problem if n is smaller than 0. I mean, we could take the absolute value of this, and then it should be always safe. But yeah, exactly. If the n is smaller and the list is infinite, that's when we'll have a problem. I mean, that's easily fixed by this, I think. Alright, and then it should always be, it should never, yeah, this should always terminate gracefully. Okay, so we need what? We need safe index of password and I. So we need to do a maybe over this, right? And if it's nothing, we need to replace it with false, and if it's true, then we need to make sure that it's equal to char is what we've called it, right? And then yeah, we need to do this. There we go. Oh, okay, I get it. We could just do like this, and it's the same thing, right? I actually like that version better. I'm not sure why I always feel it's easier to read if I put the operator at the beginning. Oh, thank you for the follow, DOGXWX. I have no idea how to read your name other than spelling it out. Sorry about that. So I think this should be everything. So I guess we only need to replace here with is valid anchor for part 2 and then run it. And I'm pretty sure, oh, well, yeah, it's the same input, right? What do you mean? Not I. Oh yeah, let me think. I didn't consider that actually. Let's think. So my thing is 0 indexed, right? We stop at 0. Yeah, I think you're right. 303. Let's see. It's so natural to do it 0 indexed. Okay, yeah, you are definitely right. It's so natural to do 0 indexed that I totally forgot that they said it's 1 indexed. I could have changed the code here because it's specific to this problem. I could have added 1 here instead. Right. So yeah, I guess that's it for the current problems with in advent of